All right. So we're going to keep on looking at functions, and we're going to start here with this graph. And you can see the graph here represents the total amount paid at a local parking garage. So depending on how long we park, it's going to affect how much it costs. So we're going to use the graph above to determine how much it would cost for 2 hours. The number of hours that I've parked is along the x-axis, and the amount of money is along the y. So I'm going to head to 2. 2 is right here. And I'm going to look, but as I look at it, you can see how there's 2 different dots here. One is a closed dot. That's where the actual value is going to be. The open circle is going to be up to that value. So at like 1.999 hours, it'd be that $8. But here, the moment it hits 2 hours, it switches over to $12. So this would be $12. Go ahead and try the other 3 problems here. So we have 3 hours and 10 minutes, 4.5 hours, and 10 hours. So take a moment and find those values. It's okay to pause the video. All right. So at 3 hours and 10 minutes, it would cost $16. 4.5 hours is going to be $20. And 10 hours is going to be 24 hours. There we go. So as a reminder, the domain is the set of the inputs, or x values. And y is the set of the outputs. Range is set of the outputs, or y values. Until I'm still waking up. So as we look at it, this would be my domain from left to right, and this would be describing my range up and down. We can use the vertical line test to tell if something's a function. If no vertical line intersects a given graph in more than one place, then the graph is a function. So go ahead and imagine a vertical line going across here. Right? You're good, 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 good. So do you agree that I can't draw a vertical line and have it intersect more than once? So this one is a function. The vertical line test is great for determining it from a graph if something's a function. This one's equation would have been x squared y equals 4x minus y. It's a lot harder from that equation to tell if it's a function. This one, you can tell right away that it's not going to pass the vertical line test right there. Boom. Okay? Its equation looks like y squared equals 4x squared minus 1. This y squared here, notice the last one didn't have any y squareds in it. This y squared is what's creating it not to be a function. And that's because if I go to isolate y, I would square root both sides. And when I square root, I would need to put a plus or minus in front of it. That plus or minus is making one input go to 2 outputs, and that's what's making it not be a function. So if I'm looking from an equation and I want to determine if something's a function or not, I'm going to look for y to even powers or plus or minuses. Those are the kinds of things that highlight to me that it won't be a function. Those are not the only options that would create it not to be a function, but there's some big hints in it. So the next one, is the following relation a function? We check with the vertical line test. Yes, it's a function. Now we want the domain and the range and the zeros. So the domain starts here at -1, and it goes on forever. We can tell it goes on forever because of the arrows. So I'm going to go in interval notation, which means square bracket to include the -1, to infinity, and a rounded bracket there. You could also write it as x, I leaned on something, is greater than or equal to -1. So this is what's called interval notation, this first one, and this one is inequality notation. Next, our range. The smallest y value we see is 0. It's including it, and then it goes up forever. So we'll say 0 to infinity, including the 0, or we can write y is greater than or equal to 0 in inequality notation. My zeros are where we're crossing the x-axis or touching the x-axis, and it happens twice, once there and there. So -1, 0 and 0, 0. Take a moment and finish off the last couple problems on this page.